Let's have a little look now at how we do question 2. So we've got an object of mass 7 kilograms is being pulled vertically upwards by a rope. The acceleration of the object is 2 meters per second squared. And we've got a little diagram. It's being shown that's going up. It's held on the rope, and here's our object. Now what we're going to be asked, what is the tension in the rope? So, first thing we need to do is work out what's going on. Well, if we've got a mass that's being accelerated, then the force will equal the mass multiplied by the acceleration. I can put some numbers into that, so I can say my force is equal to my mass of 7 kilograms multiplied by my acceleration of 2 meters per second squared, and that will give me a force of 14 newtons. Now what we need to be careful here is the answer isn't A, because of course in F equals ma, F is the resultant force. So if we go over to the diagram, we can see that we've got the rope which would be pulling up with a tension of T, and it's also got the weight, mg. So if I combine these two forces together, my resultant force F is going to equal T plus minus mg, because obviously the weight is acting in the opposite direction. And I can work out the weight of the object, mg, because I know the mass is 7 and g is 9.81 meters per second squared. So if I put those into my calculator and round it up to the nearest whole newton, I get 69 newtons. And now if I rearrange my formula up here, we can get what the tension is going to equal. So my tension is going to equal the force, the resultant force, plus the weight. And if I put my numbers in, that will tell me my resultant force from F equals ma is 14, and I know that the weight is 69 newtons. So if I put those again into my calculator, I come out with an answer of 83 newtons as being the tension in the rope, which is answer D. And that's how we do question number 2.